in order to understand the consumer's behavior, we had to assume that there were these preferences that were given. But where do these preferences come from? So if we were trying to model some consumers out in the real world, where would we find these preferences? Well, when we look at data, we would be able to actually estimate these preferences. And what we're going to do is use this notion of revealed preference to understand what a consumer's preferences might be. So we'll use revealed preferences to make inferences about consumers' preferences. So what we're going to assume is that consumers are maximizing their utility subject to some budget constraint. So every consumer has some income, they look at some prices, and given that income and prices, they're going to pick the best bundle according to their preferences. That's what we're going to assume. We're going to see what the consumer picks at various budgets. So we're going to change the prices, we're going to change their income, and we're going to look at what they pick. And from that data, we're going to be able to estimate what their preferences are. So let's look at this scenario, for example. Let's suppose that the income and the prices are such that the budget line is L1. So we know that we can observe the income and the prices. What we can't observe are the preferences or the utility function. So we can observe the income, we can observe the prices, and we can observe what the consumer chooses given that income and prices. So we see that the consumer is facing the prices and income that define this budget line L1, and the consumer picks A. Well, if the consumer were to pick the bundle A, what we know is that they could have picked the bundle B because they can afford B. Yet they chose to pick A. And they did not pick B. So they're revealing to us, by making this choice, that A is preferable to B. So we say that A is revealed preferred to B. Now let's suppose we see some other data point that describes this other budget line, L2. And when L2 is the budget line, we see that the consumer chooses B. The same consumer. But the consumer could have chosen C instead. But they didn't. They did not choose C, they chose B. What this reveals to us is that the consumer thinks B is better than C. Now this consumer has revealed to us that they find A better than B, and they find B better than C. So then they've actually revealed to us that A beats C as well. So we can actually use this sort of a transitivity of preferences to back out what their preferences might be. So by the same argument, when they pick A, they reveal to us that everything here is worse than A. And if from this other budget line, L2, they pick the bundle B, then they reveal to us that everything else under here is worse than B. And since B is worse than A, everything under this second budget line is also worse than A. So everything in the shaded area is actually worse than A. Now, remember, we've assumed that preferences are monotonic, or that we've assumed this notion of more is better. So any bundle in this shaded area contains more of both goods. Therefore, it must be that any bundle here has to be better than A. So we can infer then, we can assume that all these bundles are better than A. Now let's suppose there were some third budget line So some third data point where we observe income and prices that describe this budget line, and it passes, let's say, through A and D, but the consumer picks D and does not choose A. What that means is that the consumer reveals to us that they think D is better than A. If D is better than A, then anything that's better than D, remember by the more is better idea, everything that's in this region is better than D. And we've already had the consumer reveal that D is better than A, therefore anything here is better than A. So anything in the shaded area then has to be better than A. Similarly, we could do this again. Let's say we have one more data point, L4. And again, the consumer picks E. They could have chosen A, but they picked E. That means that they think E is better than A. Then anything that's better than E has to be better than A as well. So all this stuff is also better than A. So we can keep doing this for as many data points as we have. Now we've also assumed that preferences are convex. So any combination of two bundles that are better than A is also better than A. So what we know is that at this point, we've been able to identify all this stuff up here that's better than A, and all this stuff down here that's worse than A. So we're getting pretty close to identifying where the indifference curve needs to be. The indifference curve would have to pass in this unshaded area. We haven't pinned it down exactly yet, but we're starting to narrow it down. If we had enough observations, if we had many observations, we would be able to get it exactly. But if we have fewer observations, we could still get a pretty good estimate of what it would be. So we can get an approximation.